Thank you, Ralph. I'm first going to apologise because I will cough during this talk. I've been coughing since September 2023. Something to do with my sinuses. Then I spent 24 hours on planes. Now I cough more. So I'll try to do this. Hence the hand mic. So yes, I'm Martin. I work at DDN, home of the world's greatest data intelligence platform. And I'm here to deliver the CTDB report for 2025. The last time I did this was 2022. So I'm going to talk about what's changed in CTDB since then, which is not a lot. But what I'm going to try to do is share some discoveries and some understanding with people, because there are some things that haven't been obvious to me. So if I can share those, then that'd be great. I'm going to talk about the little bit of stuff that's in the queue for CTDB. Some of those things have been sitting there for years, and they really should be dequeued and put upstream. I have 20 work in progress branches. Some plans for things that we need to do soon. And then if there are any questions, insults, bottles to dodge, please be kind. Who's the audience for the talk? Well, everyone. It's kind of a developer talk, but it's going to be fairly dense. It's going to be quite full of information. Let's see how we go. So first of all, we take a look at clustered Samba and figure out where CTDB fits into that. So for those of you who don't know CTDB, it's used to cluster Samba. It's also used to cluster NFS, which is something you'll hear a lot about in this talk. We have SMBDs and winbinds on various nodes. They store data in TDBs, and CTDB manages the data in the TDBs. It also handles failover of what CTDB calls public IP addresses, and other things call those virtual IPs, things like that. The winbinds can talk to Active Directory servers. We can have SMB clients, and we can have NFS clients by throwing an NFS server onto each node. So I think I've said most of that. CTDB manages two types of databases for Samba. There are distributed volatile databases which turn out to be lossy. If a node crashes, we lose the data. And at the moment, because we don't support persistent handles, this means it's fine. The client just reconnects to the node that takes over the service and retakes locks, retakes all of its state, share modes, blah, blah, blah. And that's all stored in these fast distributed volatile databases. Then we have replicated persistent databases, which are slow. Data has to be pushed to every node, and we really only get a small number of 100 transactions to those databases every second. So it's really quite limited. However, if you commit your transaction successfully, the data is guaranteed to have been written to the databases on all nodes in one theory of the world. So CTDB also provides a cluster-wide messaging transport, so SMBDs can even send messages to each other. There's cluster management involving, which is the leader node, and is a node in the cluster. There's this dynamic IP address failover, so that you can have redundancy, and there's service management. CTDB starts, stops, monitors, SMBD, winbind, all the services, as well as the network interfaces and things. It's good that we're resuming a backup. I'm glad you know that. So, progress in the last 3 years. And I don't put this up as some sort of ego trip, because even 251 commits in 3 years isn't very exciting. we're not abandonware, but we're not doing super fast development. One of the reasons for this has been spoken about at previous sambaXPs, and you know, CTDB is a brilliant prototype contributed to by many, many smart people, but never actually restructured so that a new person who comes in who wants to touch, say, just failover can go, there's the failover code. I'm going to make a little change to that. They need to learn a whole bunch of stuff, which comes up to about here, and then you have trouble breathing trying to figure out how to do the failover thing. So we need to restructure the thing and keep a whole bunch of the good ideas and also be able to incorporate third-party components. So, sorry? Well, I've got one slide on real plans, so no problem. So yes, thank you to everyone who's contributed during the last 3 years. That's cool. More thanks go to the people who reviewed patches. Amate, who used to do a lot of work on CTDB, is very busy working on something else these days, but he still dives in and does a bunch of review, as do a bunch of other people. So again, thank you. So what are the main areas that have improved in the last 3 years? Early on in that 3 years, I did some work to improve cluster lock reliability. More details to come. The nodes list no longer has to be in a file. So if you've got, if you want the cluster to be more dynamic, you can, in a Kubernetes cluster or something, you can read the nodes list from a command. There's been a lot of work on trying to get NFS lock recovery or lock reclaim, depending upon who you are. Get that working and get it working better. Not foolproof, but acceptably. And a bunch of the work has been script work. So every time we touch a script, we reformat it, we run it through shell check. We try to make sure that we get rid of the easy problems. And a lot of test additions and improvements. So, cluster lock reliability. We have a helper variable in CTDB, and the old mechanism for deciding which node was the leader used to be to run a pretty standard election. Everyone sends their credentials to each other. The node that's better keeps going with the election and sending its packet to nodes, and eventually people drop out and say, all the other nodes are better, or this other node is better than me, therefore it's the leader. Then we would try taking something called the recovery lock, fail, and ban the node, and that was bad. So before 2022, or maybe early in 2022, we replaced the election mechanism with a race for what we renamed to be the cluster lock. So if you can get that cluster lock first, you're the leader. There's no quorum. There's none of the other usual mechanisms that people have for deciding leaders in a cluster and doing membership. So we have this helper, and what it does, it takes you give it the name of a file in a cluster file system, and it takes a single F-control lock at the beginning of that file, and if it takes it, then it's successful. But if the cluster file system gets wedged, then it's really good to be able to figure that out. If somebody moves the cluster lock aside, it would be good to be able to detect that. So we added some pretty simple stuff. We added a child process that, on a timer, tries to take another lock in the file at a different offset, and it also checks the inode number of the file by doing a stat or whatever. And if things change, or if a process gets hung, we have both of those processes pinging each other and trying to figure out when we should decide that a node that is the leader no longer really has the lock. So that was a bunch of mind-numbing work, but it's made things a little better there. John Mulligan, who works on the Kubernetes thing, and I am very sorry, is it called the Samba in Kubernetes project, or is it called something subtly different? I meant to look it up before standing here in front of you. And now I feel like a fool because I've probably got it wrong. So yeah, got it right? Woohoo! All right. So now we can call a command to generate the nodes list, and that apparently works quite well. We do need to fix a problem where the nodes list is read by the main CTDB process, which must never block, but at the moment it runs a command and effectively waits for it. The command had better be quick. So we need to dive back in and fix a little issue there and basically make that asynchronous. Then we come to the fun of lock recovery and reclaim in NFS. Basically what happens is on failover or server reboot, NFS clients need to re-establish their state. And in NFS 3, they get told, hey, the server rebooted, because it's a stateless protocol, and they get told the server rebooted, and they go, oh, yes, okay, I'd better reconnect, take my logs, and that's all very good. NFS 4 is different. So a few years ago, we were doing stuff on Red Hat distributions, and they changed the user who ran rpc.statd to be RPC user instead of root. Now we needed to do a whole bunch of things as root, so we did the thing that everyone would do as the quickest hack possible, and we added a sudo as file and said, right, RPC user can sudo to root and rerun this script, which is a terrible, terrible solution. But it was quick, so we undid that. And in undoing that, we now need a way to access the IP addresses that a particular CTDB node is hosting, the public IPs or virtual IPs. And this changes, and we used to just call the CTDB CLI command, CTDB IPs, to figure out which IPs we're hosting. But now, because we're not running as root, because this script is run by rpc.statd, we're no longer running as root, so we can't get to the CTDB Unix domain socket to talk to it. So instead, every time CTDB moves IP addresses, we cache it in a state file for the scripts. And, and things like this script can, or a friend of this script, actually this script can read that. Did I say script? We had speed problems. rpc.statd is single-threaded, and it calls its high availability call out synchronously. So if you have 1,000 clients reconnecting and your call out takes 0.2 of a second, I'm not smart enough to do that maths, but it's a significant amount of time, and statd is going to stall and not take any more requests over the network. That's bad. So now, the idea was we take what was previously a statd call-out script and we split it into a fast C program that takes 1/20th of the time to run and therefore is less likely to induce latency in rpc.statd. We've got mega excitement. Things go faster, we have less problems. Back before 20, why does it say 2010? What year am I thinking? Must have been about, yes, no, it was 2010, yes, okay, sorry. Half asleep, it is my bedtime right now. If I were at home, I'd be off to bed. So before 2010, this script used to write client state data into the cluster file system. Now this caused problems, so Ronnie Salberg said nope, and moved stuff to be written into a database. And the way it was done meant that the data could be very old. But it meant you no longer had problems with the cluster file system. However, the NFS4 state from NFS Ganesha is written into the cluster file system, and if we're going to fall over there, we might as well fall over here too. The main problem that we had with the old technique is that we were queuing data in the local file system. We were just effectively touching a file every time a client connected or took its first lock. And we would queue them until the monitor event that occurs every 15 seconds occurred, and then we would dequeue them into a persistent database. And therefore, if the node crashes before the next monitor event, you lose your client data and locks can't be reclaimed. So if the cluster file system is fast enough and doesn't cause any problems, write the client state straight to the shared file system, and it's much simpler logic. So that's done. And the other simplification there is that CTDB used to have its own homegrown IPv4 only SM notify command to send notifications from each node to the clients saying the server had been rebooted or that there'd been a failover. But NFS utils had a perfectly good tool to do this already. And when I delved into the documentation and commits for SM Notify, I found that they considered the files on disk to be the format to be a stable format, basically a stable API, and it hadn't changed in over 10 years, or probably longer. So I decided to just write the sorts of files that it writes and then run SM Notify. So not exciting, but we get rid of some custom code. Less code is good. All right. Now we get to the exciting part. It is going to get exciting. Who's with me? Who's excited? Ralph's excited. Nobody else is excited. All right. So, failover in CTDB used to have 3 events. I'm going to release an IP, I'm going to take it on another node, and then I'm going to, on all nodes, say IP reallocated, like end the failover. Now what's the problem there? The problem is really, really, really simple. Let's say you have 3 server nodes, X, Y, and Z, and you have client A currently connected to node X and holding a lock. You have client C connected to node Z, blocking to try and take that lock. Node X fails, you're failing over the address to node Y, which means the NFS server on node X needs to release the lock. And what's supposed to happen, and what was happening, is that nodes X and Y were putting their NFS servers into grace. But you've got this person over here, this client C connected to node Z, blocking, ready to take the lock as soon as it's released. So it was easy to steal locks. So the first thing we did was to add this start IP reallocate event. And the only thing it does at the moment is in the NFS Ganesha call out, which is mentioned below, is it puts the node into NFS grace, which means that's the period where clients are allowed to reclaim locks they had before. That work was done by Vineet, who used to be a colleague on my team and is now having a joyous time at IBM. So that's good. The other thing we did there is there was a 06 NFS event script, which handled some associated release IP pre and take IP pre pseudo events. Of course, with our start IP reallocate, we don't need that. That nonsense is handled already. So we drop that script, we drop those events. NFS Ganesha call out. So to manage NFS, CTDB uses a 60.nfs event script. So every time things need to happen, events get generated, and each script is asked to handle the current event, and it can either ignore it or do something. It's just run with some command line arguments. And we used to have 60.nfs and 60.ganesha, and that got boring because those things repeated a lot. So we invented a call-out mechanism so we could have one NFS event script, and we could have NFS Linux kernel call-out, and we could have NFS Ganesha call-out. And I didn't really understand the code in NFS Ganesha call-out. It was very confusing to me, and I tried to test it, and I could not make either of the methods for lock reclaim work. So a bunch of stuff has been done. Vineet added the use of start IP reallocate. We then realized that NFS Ganesha is communicated to via dbus, and you're starting up everything. You've told NFS Ganesha to start up. It's apparently healthy. It hasn't said it isn't. And you're trying to start your IP allocation because the node is healthy, and you say to the node via dbus, hello, I'd like you to consider, doing a start IP reallocate for me, and or I'd like you to go into Grace. And it says this, because it hasn't brought up its dbus interface yet. And then we get upset and we say, bad node, ban the node. But that seems like a bad idea just because a node is starting an NFS server. So we try to recognize the condition where the NFS server hasn't started up and isn't listening on dbus. And we ignore that, we be kind. We've added support for the Lustre file system. And in coming versions, we're about to drop this whole idea of supporting various file systems and behaving differently. Because sometimes there are grace problems with NFS Ganesha, and we have customers who say, I'm not really doing any locking over NFS. I'm sure about that. And we go, okay. Set the grace timeout to 0. You'll never go into grace and you'll never be able to reclaim locks. Set it to 10 seconds. Things might be better. Set it to 20 seconds. Things might be better still. But, it's a fallback to try and handle things a little better. This script calls out to some Python code already, what used to be a shell script. So this young fellow who recently joined the team, he's actually my big brother, Peter. He said, we were discussing this, and he said, well, why don't we just rewrite this in Python? So, yep, we did that. He did that. The other thing we noticed, and there are still hoops to jump through because of the way that NFS Ganesha, with its recovery FS backend, handles lock recovery. But our good folks at IBM working on NFS Ganesha, they have recently done this incredibly sane thing and added IP-based recovery. Now, if you're always failing over IPs, this sounds like a really good idea. I never understood why it was done the old way. It was node-based. So they've added an option to do IP-based recovery and implemented it in the Rados backends, but not in the recovery FS backends. So Peter's probably sitting up right now when he should be going to bed, trying to understand exactly how to get rid of the corner cases there. So that's happening. So that involves writing NFS Ganesha code and really simplifying this call-out script. And the hope is that this script comes out of the doc examples directory for CTDB, where it's been living for a long, long time, and ends up being supported. And the reason it's in doc examples is because Amate didn't understand it, I didn't understand it, and we were the ones who would have had to support it. So we accepted the code and we went, ha, doc examples. So here we are. All right. Hang on. A bunch of miscellaneous stuff. These are some of the bigger contributions in recent years. SMB multi-channel, the way it was done in SMBD meant that CTDB could crash because of the way connections were, the way sessions were combined, I guess, and the memory handling was originally done. So Metz did some fixes there. That was good. One thing with NFS monitoring is that just quickly, am I nearly out of time? I can't remember. Okay, cool. So with NFS monitoring, we use the standard NFS utils RPC info thing to effectively send a ping to an RPC service. Now, if the server is really busy, that ping might time out. And then we might count a few of those, and after a few such failures, we might mark the node unhealthy. And back about 10 years ago, Malahal, who used to work on NFS Ganesha at IBM, would say to us, why don't you look at the statistics and see if NFS requests are moving? If they're moving and you get timeouts, you can ignore the timeouts because the server's not dead. Because when we get timeouts, we often will try to restart the service. And that didn't hit me until fairly recently about how you would actually do that. It's pretty easy to do. So we implemented that for NFS Ganesha, not for kernel NFS yet. A couple of years ago, somebody reported on the Samba technical mailing list that, say, a TCP connection to the NFS v3 lock manager service wasn't being tracked. So therefore, CTDB wouldn't do good, resetting of that connection so that it could reconnect. So with a bunch of other changes, it made sense to finally fix that and track connections to all ports. We have this troublesome command called CTDB kill TCP, which kills the server end of connections. So we track them, we try to kill them. And we've just had a lot of bugs and a lot of corner cases in it over the years. It actually does something quite interesting and exciting if you're into packet handling. Who's into packet handling? No? Well, it's real. Excellent. Thank you, thank you. So the idea of that little tool is it sends what we call a tickle-ack to a particular socket, and first it sets up a listener to listen for the reply. So it sends a tickle-ack with an incorrect sequence number, and this is a really good way of doing denial of service attacks. So we set up a network sniff, we send out the tickle-ack, we listen for the response, which is the server saying, no, stupid, you've given me the wrong sequence number. It's 1234. And we go, cool, the sequence number is 1234, pull it out of the packet, construct a reset packet and go, and the connection dies. However, for many years, the SS command has supported the -K or -- kill option, which will do the same thing with absolutely no overhead and with Linux kernel support. Linux kernel support. So I went and tried this. We use a Red Hat derivative. We use Rocky Linux. And I checked. the kernel option isn't enabled. Enabled on Debian, enabled on Ubuntu. I don't know if it's enabled on SUSE. And the sad thing is, when you run ss-k, you can't tell if the option is supported. It doesn't return, EOP not supported or whatever. It just gives you no output and exits with 0. So I've added some support that has a try option. So it tries using this, but if the connections are still there, if this thing reports killing no connections, it tries using the old way. The good news is that I reported the lack of the kernel thing to the good people at Red Hat, and they enabled it. And now it's enabled in all the derivatives too, so the world is a better place. Gunther and John Mulligan have done some work on the Cephratos helper, which is an alternative to the fcontrol cluster lock helper I mentioned earlier. I don't know more than that. I see that code go by and go, meh. And after the last talk in 2022, this work was already queued, but Vineet and I added an unknown status to CTDB. When a node connected, it used to originally report unhealthy, and people who were monitoring the status of all the nodes in the cluster would get quite upset about this because they'd have a healthy cluster, start a node, cluster unhealthy, oh, cluster healthy again. So that was quite ugly. So unknown is better than a lie. What's in the queue? There's a few branches. Like many years ago, I wrote this connection tracking thing that we may have to decide to use instead of, using hacky means to track connections so that we can kill them later. But that included a queued database implementation, which basically, earlier I mentioned that the database implementation for statd callout used to create files in a local file system and dequeue them on the monitor event every 15 seconds. And 15 seconds is too long. But you could have a database API which says, okay, I'm going to store them in memory, and then every 100 milliseconds I'm going to dequeue. Then you don't lose a lot of data. So it's not foolproof, but it's kind of interesting. Stefan Karnia, who is not here this year, what is going on? Said, hey, you're still using IP tables. And I said, easy, I know NF tables, I can do that. It's a little harder than I thought. So that's sitting there half done. And, many years ago we started, CTDB insists on using real-time scheduling. And we have some code sitting there that we should actually merge, get into shape and merge so that it can use a better nice value. Plans. Plans. 10 minutes. I started racing. So, we found that our QA guys were doing what I told them to, which is never a good idea. If I've said anything that sounds like good advice in this talk, don't listen. I told them about the CTDB disable command, and I said it's more lightweight than shutting down the whole product. And they went, okay. So they'd run CTDB disable, and they'd watch failover happening, and they would check what are we doing? Yes, okay, we're trying to reclaim NFS logs, and our node's going into Grace to stop that, client C over here connected to node Z from stealing our lock. Are we putting the nodes into Grace during CTDB disable? Yes, we are. It's a standard failover. Are we doing it on graceful shutdown of CTDB? Nope. We're just releasing the IP addresses locally. The NFS server shuts down. The locks are released. Client C over here connected to node Z just stole all of our locks. Client C is really bad. So We can either just run a start IP reallocate event to force all the nodes' NFS servers into Grace, or we could do a whole CTDB takeover run, which is what it calls a failover thing. Gee, we could also add an optional shutdown timeout option. Ralph doesn't look to be getting violent. Sorry. Ralph proposed this in a merge request 4 years ago in CTDB wrapper, which used to be run from either our init script or from the systemd unit thingy. And it was done by running CTDB disable on shutdown. But we were in the process of removing CTDB wrapper because it was a nasty hack. And it seemed too hard to do it any other way. Of course, until I discover that we're not putting our NFS servers into Grace, it doesn't seem so hard after all. Necessity. So I think we're going to have to do that. And that will help with durable file handles, right? Do you remember this? But with durable, I thought you wanted to do a failover and give the client time to connect to the takeover node, and you wanted a bit of a timeout there to give that time to happen. Okay, good to talk about. We'll talk about it afterwards. Yep. Because I went back and looked at the merge request and just went, so yeah. The other thing I've realized is that CTDB starts a lot of processes. It starts daemons that are long-lived. It starts event scripts. It runs that node list command. This would solve that. It's a big hammer to solve it. It runs little lock helpers that wait to take locks in TDB files. And all of these different use cases are implemented separately. Wouldn't it be cool if we just had something that could run processes for us, monitor them, give us the output, handle timeouts, monitor the processes for us? We could use systemd. Yeah, it seems too heavyweight. It really does. And the other thing about systemd, hang on, I'm presenting in a conference talk, and I'm going to say the other thing about systemd. We were trying to make some changes to our management CLI, and we realized that there is no way, if you run a command as part of starting a service, there's no way to get the output on the command in your terminal. It gets logged. And you can run system_kernel status after the fact, but you can't get the output while the command's being run. And yes, I know at boot time, there's nobody there to see the output, but if it's done interactively, people would like to see that output, I think. So, yeah, and I just want this to be really lightweight, and I'm not going to try and do anything else except those 5 things. And it might just be a REST API over a Unix domain socket. Maybe JSON in, JSON out. Haven't really decided. I only just thought of the idea, but it seems like a good one. So for several years, Amate and I stood up here in front of some of you people saying that we were going to rewrite CTDB, and we were going to do such a great job of it, and it was going to be accessible to new developers, and it was going to run wonderfully. The code was going to be much more maintainable. So none of that has happened. There's been no time. So what can we do to try and make that happen? Well, Amate did write a new CTDB transport. So instead of putting structs on the wire, he wrote a new transport, he wrote a daemon. It's never been tested. Now you might say, why not write a new one in Rust? Well, we've got one. It should work. So we should write some tests and make sure that works. Then I've got a branch which has been sitting there for a few years that will tunnel blobs through the CTDB transport. You know, I want to send a blob from this node to that node. So that way we can tunnel most of the new protocols that we can come up with over the old one. And when I say most, I don't mean the database protocol, because that has to fly, that has to be fast. But cluster management, failover, all those things that just need, you know, tenths of seconds or seconds, they can be tunneled. We can pay that little performance overhead. And it actually looks like it'll be really easy to parameterize Amate's CTDB, the transport API, so that it currently uses lib messaging from Samba, but it could just use this legacy tunneling idea too. For anything but, so there's this internal protocol that we invented as well, so that, you know, for every node you want to know the uptime, you want to be able to pause the daemon, you want to be able to continue the daemon, you want to be able to ping the daemon. There are all sorts of standard things you want to do to every daemon. We should stop messing around trying to marshal and unmarshal protocols in C and do binary protocols. We should just use existing libraries and use JSON. If we do that, we might as well add Python bindings. We might as well write some of the components in Python. Lots of people know Python. It might be more accessible to more developers. So if we write, you know, some components in languages like that, then you know, people don't have to learn T-event rec, they don't have to learn this, they don't have to learn that. We can have a simple async framework and just let them plug things into it. In parallel to all that, we could actually restructure the CTDB CLI to match our components. At the moment, we have CTDB DB attach, CTDB get DB map, CTDB DB detach, and a variety of commands involving DB. Like, so why don't we then go CTDB DB verb? That seems like a sensible idea. And we can do that in parallel and change the CLI so that it can talk to the existing code that way and anticipate our future changes. And at the moment, there are some commands that produce so-called machine-readable output, which is, you know, in a format of our own invention. You know, it used to be colon separated. That doesn't work with IPv6. Let's use pipes. If we're going to transfer JSON blobs over the wire, if there's a machine-readable format, that might as well be it. We transfer the JSON over the wire. Somebody asks for machine-readable, we dump it to the terminal. So none of this seems like rocket science. So it seems like something we should be able to do fairly easily.